Bismillahirrahmanirrahim. Assalamu alaikum. This is Dr. Nosheen Tariq Siddiqui. We were doing physicochemical processes in which we were doing the miscellaneous processes. We have already covered few of the processes, which these processes I've told you, these are common in pharmaceutical preparations. They are though very small processes or simple, you can say simple processes, but they are very important in making pharmaceutical preparations. And while we are preparing pharmaceutical preparations, we have to consider these small processes very diligently so as to get the perfect preparation for patient compliance, for stability, and for other advantages. So the next processes which we are going to learn today are evaporation, vaporization, centrifugation, desiccation, Levigation, and Trituration. Evaporation. First, evaporation. What is evaporation? If we see in a simpler form, we all know that what is evaporation. In a simplest form, it is said that this is the process of turning from liquid into vapors. This, you can say it very simply, that this is a process from turning a liquid to its vapor phase. Basically, this is evaporation. But if you go on details, you'll find out there are numerous definitions of the same topic or the same head. That is, evaporation is a process of removal of solvent from the solution by boiling the liquid in a suitable vessel and withdrawing the vapor, leaving a concentrated product. Usually evaporation is termed to those liquids or to those process in which there is a certain amount of liquid which is going out and you have remained a concentrated product. You are left with a concentrated product and you are not getting a dried product. So if you get a dried product, then it's not called evaporation, it's called drying of that product. Okay. So evaporation is a process of removal of solvent from the solution by boiling the liquid in a suitable vessel and withdrawing the vapors, leaving a concentrated product. That's why it is written that leaving a concentrated product. Or evaporation is the process of a suitable substance. Evaporation is the process of a substance in a liquid state changing to a gaseous state due to an increase in temperature or pressure. Certain times you evaporate whole of your liquid to get a gaseous state because you need your solvent or whatever you have in a gaseous state. That again, it is called evaporation. Or evaporation means simply vaporization from the surface of a liquid. Vaporization of liquid below its boiling point is called evaporation. Vaporization simply, certain times it is very simple that only vaporization happens and it happens until room temperature. Below its boiling point, then it's called evaporation. Certain times you heat or you give temperature, certain times you don't. Evaporation is a process in which large quantities of liquid are vaporized to get a concentrated product by applying heat. This can also be a very concise definition. Or evaporation is the process of vaporizing large quantities of volatile liquids to get concentrated product. So these all can be different definitions of the same process, that is evaporation. So what is evaporation and what are other heating processes? Evaporation is the residue is concentrated liquid. What you get, you usually get the residue in liquid formation, while in drying the residue is solid. So it is called the process through which we evaporate all the liquid material, then we get a solid residue. Then it is, the process is called drying, and it's the process is not called evaporation. Evaporating liquid is only one component, is most of the case, While in distillation, evaporating liquid is a combination of two or more components. Usually in evaporation, the evaporation is done for a single liquid. But in distillation, evaporation evaporation of liquid is done with can be done with two or more components. No attempt is made to separate the mixture of vapor. There is no attempt which is made to evaporate those mixtures of the vapors coming out. While in distillation, it is compulsory to separate each component, or it is usually done for that. जो vapors होते हैं, they are basically condensed and they are collected basically. So the every component or every vapor is being collected at different temperature or pressure, whatever is the case. The purpose of evaporation is to get a concentrated liquid only, but not to get crystals. While in crystallization, the purpose of concentrating the solution is to get crystallization. So there it should be considered, or it should be keep in mind that the evaporation is different from other heat processes. You can say that the liquid is evaporating from those processes as well, but the final form basically it's the final procedure or the process. This is not called evaporation in those processes. So evaporation itself is a different and differential process. Mechanism: when heat applied in solution, the motion of molecules increases and molecules present in the surface overcome the surface tension of the liquid and it starts evaporate, because surface molecules have less cohesive force than the others. Here what happens that when heat is applied, तो क्या होता है, ये जो surface के ऊपर water molecules होते हैं उनकी जो है they starts to vibrate, और उसके बाद they overcome the surface tension, then that liquid, and they starts to come out from the liquid. That is called evaporation. What are the different applications of evaporation? It is also used in the manufacturing of bulk drugs containing antibiotics, enzymes, hormones, and many other substances. It is used in the manufacturing of liquid extract, solid extract, herbal extract, and dry extracts. Used in the purification of vitamins, concentration of biological products, concentration of penicillin and related products, indeterminate demineralization of water, concentration of blood plasma in serum. It is also used in the formulation of biological products like enzymes, antibiotics, and vitamins, etc. What are the main objectives? As right now, I explained to you in my previous slides. You should remember the main objectives. Now, primary objective is to reduce the volume of the product by some significant amount without loss of nutrient component. The primary objective is to basically reduce the volume of the product, of the whole of your product, without affecting the nutriting components in it. To make transport and storage easier, as evaporation decreases the weight and volume of the product. To remove large amount of liquid from product before dehydration process, and to improve stability of the product. What are the factors that affect evaporation? There are 7 factors to affect evaporation: temperature, surface area, agitation, atmospheric aqueous vapor pressure, atmospheric pressure on the liquid under evaporation, type of product required, and there are certain economic factors as well. I am sorry, I've been pausing my recording, some things. So now we'll do the factors affecting the rate of evaporation in some details. In detail, there are 7 factors. The relationship may be expressed as M is equal to Ks divided by P, which is multiplied by B minus B dash, where M is the mass of vapor formed that per unit time, S is the surface area of liquid exposed, P is the atmospheric pressure, maximum vapor pressure at temperature of air is B, while B dash is the pressure due to vapor of liquid actually present in the air. K is a constant. Now I'll see factors one by one, how temperature affects. Temperature at a given temperature, some molecules possess higher kinetic energy than average, while the other have lower than average kinetic energy. We know about the molecules that certain possess higher kinetic energy at certain temperature and some possess low. Fast moving molecule escape from the surface of the liquid into vapor, while slow moving molecules remain behind. Those who have higher kinetic energy, for example, they leave the surface more easily and they become from liquid to vapor, while slow moving, which has low kinetic energy, they tend to remain behind. When temperature of liquid is released, more molecules acquire sufficient kinetic energy and escape from the surface of the to vapor state. This situation is below the boiling point of liquid. This is still the process still is below the boiling point of that liquid. At boiling point, the vapors are formed throughout the liquid as well as from the surface. Higher the temperature, greater the value of B and have greater or higher evaporation. Next is vapor pressure. The rate of evaporation is directly proportional to vapor pressure at the liquid. The lower value of P, then greater will be the evaporation. It is directly proportional. Lower the external pressure. However, the boiling point of liquid and greater will be the rate of evaporation. You lower the pressure, greater the pressure, the lower the evaporation, and you lower the external pressure, the higher will be the rate of evaporation. Surface area, greater surface area, of course, will be the rate, greater will be the rate of evaporation, and is carried out in having evaporation. If you need a good evaporation, then you need a large surface area. Moisture contained of the feed. Some drugs undergoes hydrolysis rapidly in the presence of moisture and high temperature to present decomposition. The material is exposed to lower temperature initially to prevent some drugs, because there are certain drugs usually in which that moisture, the temperature, can decompose the material. So is exposed to lower temperature initially, then exposed to higher temperature cause the final concentration. So the moisture content of the feed is also very important. How much the moisture the compound itself carries. Type of product required, what type of product you require, that is also very important. Type of product required sometimes decide the apparatus for evaporation. Open pan produce dry concentration till evaporation, healed liquid concentration. Spray dried produce dry product with good stability. The open pan जो है वो क्या करता है, वो concentrated liquid देता है, जबकि spray dry product जो है वो product जो भी देता है, it has good solubility. Time of evaporation, it is the time exposure. If the time exposure is larger, greater will be the evaporator, provided the constituents re-thermostate. The constituent should be a thermally stable. Exposure of the drug is relatively high temperature for short periods may be less destructive than lower temperature for large periods of time. Film and deposit. When extracts are concentrated, concentration in steam pan. I'm sorry, there is a lot of spelling mistakes in there. I don't know how they get. I basically couldn't see first, but now I can see there are quite some spelling mistakes. Anyway, when extracts are concentrated in steam pan, film may be formed on the surface or precipitate matter deposit on the heating surface film, reduce the evaporation. If certain times you have seen that there are, if you evaporate something, there is a kind of film which is formed over the surface. This also affects the evaporation. The next is centrifugation. Centrifugation, what is centrifugation? If you take it in a simpler form, centrifugation is a technique that helps to separate mixture by applying a centrifugal force. Centrifugal force apply करने के बाद, if you get to separate something or separate a mixture, then it is called centrifugation. Okay. In this, we are going to discuss its history, definition, history, principle of centrifugation, classification, operation, construction, a little bit application in pharmaceutical industries, advantages and disadvantages, safety measures, importance, and little bit of summary of, I'll give you, or maybe I'm not. What is centrifugation? Centrifugation is one of the most important and widely applied research cellular techniques in biochemistry and molecular biology, pharmacy, and in medicine. Centrifugation is a process which involves the use of centrifugal force for the sedimentation of heterogeneous mixture with the centrifuge. You apply a centrifugal force to sediment the heterogeneous mixture, means a mixture in which there are numerous things. So you want to sediment, the sedimentation process आप समझिए वो ही carried out होता है, but in by applying the centrifugal force. So the process is enhanced or accelerated. The process of sedimentation is accelerated, and you get a clear mixture or separation occurs. A centrifuge is a device that spins quickly to press objects outward with centrifugal force. When you apply a centrifugal force, the product, the solid or the contents tends to move outwards. Centrifugal force is an apparent force that acts outward on a body moving around the center, arising from the body's inertia. Centrifugation is used to separate particles or even macromolecules. You can separate out molecules of different sizes. How? The bigger molecules will settle more fastly and they will settle at the bottom. The later will subsequently, the separation will be done according to the size. So because of this, you can, centrifuge and you can separate out cells, subcellular components, proteins, nucleic acids. What is the basis? Basically, basis is the size, shape, and density. These things which you can keep in mind, and you can separate these cells, subcellular components, proteins, and nucleic acids. A short history, how it is conceived, basically, how the whole of the process is conceived. It was not done in a day, but gradually there are a few things which were made and that give an idea to enhance it or to modify it. Then finally centrifuge was developed. So the basic idea was the English military engineer Benjamin Robin invented a whirling arm apparatus to determine drag. He first basically invented an apparatus. Then later in 1864, Antonin and Branded proposed the idea of a dairy centrifuge to separate cream from milk. The idea was subsequently put into practice by his brother Alexander Branded, who made improvements to his brother's design and exhibited a working butter fat extraction machine in 1875. The potential of the centrifuge in the laboratory setting was first exploited by Frederick Meisner. In 1869, Meisner used a crude centrifuge system to isolate a cell organelle. This process led to the discovery of an important new class of biological constituent, later to be known as nucleic acid. He discovered this nucleic acid by the use of a machine which was similar to the centrifuge now used nowadays. The work of Miser was quickly recognized and developed further by others. In 1879, the first continuous centrifugal separator was demonstrated by Gustav de Level. This development made the commercialization of the centrifuge a possibility for the first time. Means from 1707, then 1879, the final apparatus was formed. What is the principle of centrifugation? If you consider its methodology, it utilizes density difference between the particles. Basically, it utilizes the density difference between the particles and the medium in which these are dispersed. Of course, the medium and the density of the particles. Dispersed systems are subjected to artificially induced gravitational field. The centrifugal force causes the sedimentation of heavier solid particles. Okay, so the main thing which you should keep in mind is the densities and the medium in which it is dispersed, the densities of both the dispersed medium and the particles in it. So after applying the induced gravitational field, that is after applying the centrifugal force, the separation occurs. A particle is subjected to centrifugal force when it is rotated at high rate of speed. The centrifugal force F is defined by the F is equal to m omega 2r, where F is intensity of the centrifugal force, m is effective mass of sedimenting particle, omega angular velocity of rotation, and r is the distance of the migrating particle from the central axis of rotation. Principle of centrifugation, a more common measurement of F in terms of the Earth's gravitational force G is relative centrifugal force. Relative centrifugal force, it's defined by RCF, and it is around 1 to 1.119 into 10 raised to 5 power 5. This equation relates that the relative centrifugal force to revolutions per minute of the sample. Equation dictates that the RCF on a sample will vary with R. That is the, what was the R? R was the distance of migrating particles from the central axis of rotation. The distance of the sedimenting particle from axis of rotation, and the RCF value is reported as a number times of gravity. Classification of centrifugation. The types of centrifugation depends on the basis of speed and the temperature. The speed of the centrifugal machine and the temperature you are doing that. There are various types of centrifugation: differential centrifugation, isopycnic centrifugation, sucrose gradient centrifugation, and ultracentrifuges. What are differential centrifugation? Differential centrifugation is a common procedure in microbiology and cytology used to separate certain organelles from whole cells for further analysis of specific part of cells, undergoes tissue disruption and cell lysis, finally centrifugation. The basis is that if you can see from the diagram, the organic material or whatever is there, they are put in a test tube and they are rotated, and the whole of the material, it gets the material is rotated like blood or things like that, and it is centrifuged. And before centrifugation, they have cell material in the blood which is present. Then after the centrifugation, you get all of the cellular material which was suspended in the blood. They get collected at one place, and you get the serum or the plasma. Okay. Isopycnic centrifugation. In this type of centrifugation, also called as equilibrium separation, particles are separated solely on the basis of their densities. The particles are there separated. The higher density and the lower density particles, they are separated basis on their specific densities which they possess. Particles are separated solely on the basis of their densities. Particle size only affects the rate at which particles move until their density is the same as the surrounding radiant medium. They get the, solution which you used is also, it has different gradient or medium. So they tend to, they remain on the place where they have the similar density of the solution around. So the separation occurs. Particle separates out according to their buoyancy, used to isolate nucleic acids such as DNA. The next is sucrose gradient centrifugation. You only have to understand in this that in this vial or the centrifugal tube, you provide with a different sucrose gradient. It's somewhat similar to the previous one, but in this you are only using sucrose. So while the when you have different sucrose solution, the separation occurs according to this gradient of the sucrose sample, and you get the separation according to their densities. Ultracentrifuge is a centrifuge optimized for spinning a rotor at a very high speed, capable of generating acceleration at about higher than 19,600 km per second square. There are two kinds of ultracentrifuge, the preparative and the analytical ultracentrifuge. Both classes of instrument find important use in molecular biology, biochemistry, and polymer science. Okay, laboratory centrifuges. There are different types of laboratory centrifuges. There are microcentrifuges, clinical centrifuge, and multi-purpose high-speed centrifuge. Industrial centrifugation. An industrial centrifuge is a mechanical use for fluid particle separation. Industrial centrifuges can be classified into three types: filtration centrifuge, those using perforated basket, which perform a filtration type operation, but under centrifugal force, means the filtration is done quickly with a by applying centrifugal force. And sedimenting centrifuge, those with a solid walled vessels where particle sediments towards the wall under the influence of centrifugal force. Tubular bowl centrifuge, continuous centrifuge, those where a continuous process or a very high capacity is required. Advantages and disadvantages. What are the advantages? Centrifuge have a clear appearance and have little to no order problems. Not only is the device easy to install and fast at starting up and shutting down, but also only requires a small area of operation. They can be selected for different applications. The device is simple to operate, while centrifuge has more process flexibility and higher levels of performance. What are the disadvantages? The machine can be very noisy and can cause vibration. The device has a high energy consumption due to high gravitational force and high initial capital costs. You must always remember these safety measures, because centrifugal machine, it looks very harmless, but because it is using a great amount of centrifugal force, so that the things which you are putting in can be damaging as well. A centrifugal user should strictly observe the following precautions. Number one, manufacturer's manual should be strictly followed. You should always consult the manual before starting work on centrifuge. Rotor should be stored in proper containers. Attention should be given to the imbalance detector. Rotor speed should not exceed the assigned speed. Lid of the rotor chamber should remain locked during the operation. This is very, very important, extremely important. To avoid the rotor failure, manufacturer's instructions regarding rotor care and use should always be followed. What are the important? Centrifugation play an important role in both biological sectors as well as industrial sector. And biological sector, medical laboratories use centrifuge to separate plasma from heavier blood cells, while modern centrifugation can even separate mixtures of different size molecules or microscopic particles such as parts of cells. Industrial sector, cream separation from milk, separating textiles, separating particles from an airflow using cyclone separation, clarification, and stabilization of wine, which we don't do. Centrifugation is the most common method used for uranium enrichment. Next process is desiccation, and we all know this is a very simple process, but we'll still go through it. General introduction में क्या है? Desiccation is the state of extreme dryness or the process of extreme drying. A desiccant is a hygroscopic substance which which absorbs water molecule that induces or sustains such a state in its local vicinity in a moderately sealed container. It should always be kept in a sealed container. A desiccator is a heavy glass or plastic container used for making or keeping small amount of material very dry. The material is placed on a shelf and a drying agent or desiccant such as dry silica gel or anhydrous sodium hydroxide is placed below the shelf. Basically, the desiccator is of two shelved होता है ये, और ये आपको यहाँ लैब में मिल भी जाएगा. इसमें perforated सी area होता है बीच में, and the lid is very hard so that the air from atmosphere do not enter the container. And below the below area of the container or the below there are two compartments basically. The upper compartment you keep your material, and the lower compartment you keep the desiccator in it, such as silica gel or anhydrous sodium hydroxide. Desiccation is the process of removing adhering moisture from liquid or solid substances. The term desiccated is used for those substances from which the water or moisture has been completely removed. What is this simpler process? On a small scale, desiccation can be carried out in a desiccator, which consisted of a tightly closed glass or plastic well, as I've told you, containing a drying agent at its bottom, which absorbs the moisture from the substance being desiccated. Commonly used desiccants are concentrated sulfuric acid, phosphorus pentoxide, exsicated calcium chloride, and silica gel. The drug or substances to be dried is taken in a china dish and placed inside the desiccator above the surface of drying agent. For continuous operation, the desiccator may be sometimes connected to a vacuum pump. So there is the moisture which is coming out can, from vacuum, you can remove those moisture contents. The moisture sensitive substance formulated in tablets and capsules are protected by enclosing them in a sealed vials, on bottom of which a small cloth bag containing silica gel is placed, which act as a desiccant. And you must have noticed and seen that. In case of organic solvents, the traces of moisture are removed by passing them through a column of ammonia or silica gel. Its application in preservation of vegetables and animal drugs that are destroyed in presence of moisture. Communication of drug is difficult when they are wet, but it becomes easy when they are dried. To decrease the bulk and weight of the substance containing moisture to facilitate their easy handling and to increase the stability of drugs. Next is levigation. Levigation is commonly used in small scale preparation of ointments to reduce basically the particle size and grittiness of the added powder. Basically, you levigate the ointments to reduce the particle size more and to basically reduce the grittiness of a powder. When you add a powder to a petroleum jelly or anything else, there is a grittiness, and the ointment should be smooth, the smooth to apply. So for that, you levigate. A mortar and pestle or an ointment tile is used for this purpose. A paste is formed by combining the powder and a small amount of liquid in which the powder is insoluble. The paste is then triturated in a mortar and by pestle or on the ointment tile by a spatula to reduce the particle size. The levigated paste is then added to the ointment base, and the mixture is made uniform and smooth by rubbing it together with a spatula or the ointment tile. The most common levigating agents are mineral oil, water, alcohol, and glycerin. The process of levigation is also known as wet grinding and is used to reduce the particle size of a substance to final state of subdivision. This process is often used to incorporate solid substances into dermatological and ophthalmic ointments and suspensions. Applications, size reduction and preparation of ointments. Next is, probably it's the last, trituration. Trituration may be used to both comminute and to mix powder. By triturating, the grinding of a solid substance is done to fine powder by continuous striking or rubbing the particles in a mortar and pestle. Trituration is without the addition of any liquid material in it. Okay? If simple admixture is required without special need for comminution, the glass mortar is used preferably. When a small amount of potent substance is to be mixed with a large amount of diluent, geometric dilution method is used to ensure the uniform distribution of the potent drug. You do it gradually, or little bit is added after little time. This method is especially indicated when the potent and other ingredients are of the same color and a visible sign of mixing is lacking. By this method, the potent drug is placed on an approximately equal volume of the diluent in the mortar and mixed thoroughly by trituration. Then a second portion of diluent equal in volume to the mixture is added and the trituration repeated, and so on. You are adding bit by bit. This process is repeated until all the diluent or the components is incorporated. What is its application? Size reduction के लिए use होता है and geometric mixing of powder. Geometric mixing of powder क्या है कि आप थोड़ा थोड़ा करके powder को they are mixing those powders. Thank you. That's all for today, and we have covered our all the topics under physicochemical processes. We will start our next topic from next lecture. Thank you.